All right, hi calculus. Here is my attempt at doing some work without a whiteboard or a chalkboard, okay? So when we left class, before spring break, we had finished lesson 7.5, which was about reasoning using slope fields. So today we're going to take some notes on lesson 7.6, which is finding general solutions using separation of variables. If you have your note packet, this is on page 12. So it's this page right here. I'm just going to be doing the exact same things, just I'm going to write them in my notebook instead of on this paper, okay? So it starts off with saying some differential equations can be solved by separation of variables. Once the variables have been separated, anti-differentiation can be used to find the general solutions. So the first thing we have to figure out are the differential equations we have able to be separated. So the first one asks is dy over dx equals x times secant of y separable. So can you separate that thing? All this means is, can you get all the variables, the like variables, on the same side? Can I get the dy and the secant y on the same side of the equal sign? And can I get the x and the dx on the same side? So yes, because if I cross multiply here, I would have x times dx if I bring this dx over here. And if I want to bring the secant y over, this is going to be dy over secant y. So yes, it is separable because I can separate my x's from my y's. Okay, then the next one it says is dy over dx equals e to the x times secant xy separable. So let's check. I can bring my dx over here, so I'd have dy equals e to the x times dx, but I still have my secant xy over here. Now, the problem is that my x and y are both inside this secant function, so I'm not going to be able to take that x out so it can stay here, and I can't take this y out to move it over here. So no, this one is not separable. Okay, so this is one thing you're going to have to figure out. Okay, so now once you know that, you can start solving some problems. Example 1 says to find the general solution to this differential equation. Dy over dx equals 3xy squared. So let's find the general solution to this. Example 1, we're still on page 12. All right, so example 1. So let's see, first we have to see if we can get our y's and our x's together. So I'm going to move this x over, so I'll have this dx over. So I have dy equals 3xy squared times dx. Okay, now to completely separate this, I need to get this y over here, and that'll work out because I can just divide it out. So what I end up with is dy times 1 over y squared, right, because I'm dividing by that, equals 3x times dx. Now that my differential equation is separated, the variables are separated, I can use anti-differentiation to solve it, right? So this is where you're going to take the integral of both sides. So if I take the integral of 1 over y squared dy and the integral of 3x dx, what do I get? So this would end up being, making sure we're still on the screen here, yep, this would end up being y to the negative 1 over minus 1, right? Because this is y to the negative 2. Negative 2 plus 1 is negative 1. And over here, we end up with, take that 3 out, x plus 1 is x squared over 2. And now, because this is a general solution, we don't have bounds here, we have to add our plus c. It doesn't matter which side you add it to, I'm just going to add it to the side with the x. Because now I can rewrite this to say negative 1 over y equals 3/2 x squared plus c. And if I really wanted to, I can make this y equals by getting rid of that minus 1. But I don't need to do that right now. I can just leave this as our general solution. So this would be the answer. It's general because it's got a plus c versus a defined c. All right, so you will notice on that same page that there is something where it says to match the differential equations with the general solution. So it looks like, let me get it in there, looks like this on that same page 12. If you don't have that, you can use this one I'm putting up right here, or remember this is on Google Classroom under Unit 7 Notes. I want you to pause the video right now and match those up. Match the columns with the, match the solutions with the differential equations. And then when you have that done, unpause the video and you can check the solutions. Right, so go ahead and pause that video and I'm going to put the solutions up. All right, and here are the solutions to that once you've tried it, okay? So you can check through that. All right, so that was page 12. And now if you go to page 13, it looks like this. It's actually a page we've done before, right? It's got all the slope fields and it says to match the slope field to the differential equation. So this is exactly like what we did back before spring break when we did our lesson on slope fields. And I want you to go through and separate the variables on that and find the general solution to each one of those differential equations on page 14. And then once you've done that, you're going to go ahead and match, okay, which does my general solution, which slope field does it match? So you're going to do all that work on the next page, which is page 14. And remember, if you don't have it, you can go onto Google Classroom and look at the note packet and look at page 13 and 14. So go ahead and pause and try that. And then when you're ready, just hit unpause and I'll have the solutions up here. All right, and so here are those solutions. So there's 1 through 6. Hopefully you can read my work. Pause it if you need to. And then here are 7 through 10. So really, you're just separating the variables and then integrating each side. And don't forget that plus c because it's a general equation. All right, so that's where we're going to pause on this little video. The next video will be on lesson 7.7 where we are going to move from general equations to particular equations. See you later.